Welcome to another episode of my construction video and my practical construction video. I call it practical construction video because I try to make everything simple in the practical way as if we are on the field. So I try doing it as if we are on the field so it will be easy for future engineers that will be on the field, or if you are on the field and you still don't understand some things on how it is being done on the field. So welcome to another episode of my practical construction video. So in this part, I started with the part one. I started with bar bending schedule, and in this part, I'm going to be doing an example of how I came up with the table of bar bending schedule. So I'm going to be doing that, and we are going to be knowing the total number of enforcement we need for the job in this video. So join me and let's begin. I hope by at the end of this video you are going to add a knowledge to. So we are going to do a power bending schedule on this, just like the previous video to part one. This is what I did, and this is what I show you from the previous video. So, and this is the shape I have from the drawing of the previous video. But now I'm going to be showing you how all these are being done. So I did for this beam, that's why I put it side by side, so it will be easy to to put in the value and all that. So I'm going to shift this down. I'm going to extend this now so I can do for this side. So I'm going to copy this, and the reason why I will copy this is to make the work easier, so we don't need to introduce new thing. We just need to uh, do some adjustment on those ones. So let me leave it at that. Let me leave it at this. So let me do for this beam. I can move this up now. So I can just move this down. I can move this down to this part, so it will not be difficult for me in bringing my value. So I can title this as beam 2. You can say beam 2. So I can say that is beam 2. Then the description of the beam is beam 2 and beam 3 G to A, and it is 230 by 300. So I can edit this to beam 2 and 3. This is 2 and 3, beam 2 and 3. Then I can shrink this later, but let me just continue with the video. So what is the first thing I'm having from this? So I'm having this reinforcement at the top, this reinforcement at the top, and it span to this area here. So I'm just going to measure it. That's the reason why I love doing my bar bending schedule from AutoCAD. It's going to be easy to measure the actual length than getting it from the drawing. So I have this value here. Let's say it is 4,000. So let's say it is 4,000, then plus a crank here, which is 300. Then that is going to be 4,3. So 4,3, I'm going to edit this and put my 4,3. Then how many is it? If you look at the quantity, how many is it? It is 3 number. 3 number here, right? 3 number. So that is 4,3 multiplied by 3. So what do I have? My calculator. I can just say 4,3 multiplied by 3. I have 12,900. 12,900. 12,900. So I have 12,900, and this is the shape of the bar. This is the shape of the bar. So I can just edit this to be 4,000, right? Yes, it is 4,000. No. So I can just say this 4,000. So I'm done with the first bar. So that's how to do the bar bending schedule. I'm done with the first bar. So any person using this drawing, probably the iron bender, will just know that for this length, I'm going to cut an reinforcement of 4,3. I'm going to measure 4,3 from a length of reinforcement and cut three pieces of this length, then bend it at 300 each, and that's it. And you can probably even crank it or just leave it and do your work, and that is it. So let's go to the other one. This is okay. I have this reinforcement here. So this is two 16 bar reinforcement at the top. So let me just measure. Can measure from here, and to this part I have 5 9. Okay, let's say I have 3 6. Let's say it is 3 6. I can just come and it is 2 at the top. So I can just come here and edit to 3 6. It is 6. It is 16 reinforcement. So I can just say this is 3 6. It is 2. And 3 6 multiplied by 2. And here that will have, that should be 7 2, right? 7 2. That is 7 2. So I can just come and just it does not have any crank. If you look at it, it's just a straight bar. Now you might be looking at it from here that it has a crank. No, the reinforcement at the top is one that is going to have the crank. The other reinforcement will not have this crank here. So that is how it is done on site. Other reinforcement will not have. So I can just label this to 3 6. I can just change this to 3 6. So an iron metal looking at it, just know you just need to look to it does not, you just need to cut this length 3 6 into two places and just don't bend anything. Just a stretch of because it's just a long reinforcement, and that's so I can still come to this third part here. And so let me take my measurement as usual from here and stop here. So I have 3738. 3738, and I'm going to add 300. No, 3738. So I can just use my calculator. 3738 plus 300, the crank. Okay, 4038. Okay, it is it. 4038. You can decide to say 41. You can decide to say 4000. You still have your value. So yeah, I'm going to have it to be 8000. 8066. Is that 76? 8007. That is 76, right? So remember I said this is 3738. 3738. So you have for this. So I can come for the bottom bar. Okay, done with the top bar. So I can do for the bottom bar. This is for the runner. So the cursor is showing it that this is for the runner. So I can just come for this and take my measurement. So I have 7135. 7135. Then I can add my 600, making okay. Calculator. Plus 600. So I have 77. Okay, let me just leave it at this. Let's say 77, and it is two numbers. No, I have 35, but I just want to remove the denomination, the 35 at the back. I just want to remove it. So I'm going to have this, right? Just like the previous one. So I'm going to have this is the bottom bar. That's it there. So what else? So my runner, my runner is looking at the drawing. My runner is 2 multiplied by 3, 12 reinforcement. 2 multiplied by 3, 12. You can get it from here as well. So it's telling me that I have 6 reinforcement. If you look at it from the section, I have 6 runners, 6 12 runner. So it is yeah, it is 6. Look at it. That's why I have this value. It is 6, and the diameter is 12. So the length is 7 1. How do I know it is 7 1? I just take my dimension from here and measure one of it. This is 7150, so I can say 7 1. So 7 1 multiplied by 6, I'm going to have this value here. So my ring, as usual, just like I did in the last video, how to know the length of the ring we need to cut. So the ring is 10 mm and the starting number. How do I know the starting number? At this section I have 18 and at this section I have 12. 18 plus 12 is 30. So the quantity I need is going to be 30. The diameter is 10. So how do I know the length? I'll just come here. So how do I know the length? So to know the length, it's going to be 900 minus 50, 230 minus 50 plus the hook length minus the bent, minus the bends. So where's my calculator? So I can say 850 multiplied by 2, then plus 180 in two places, plus another 180, plus the hook length here, which is 200, that's 100, which is 200. So I have this value here, then subtract, I'm going to have bend deduction 90 degree into 3 places, that is 80 plus 135, that is 140. Altogether 140. I'm going to subtract 140. So that's how I came about 2120. So that's how I came about 2120 as my length. And multiply by 30, I'm going to have this. Then I draw the section out for any for it to be easy for anybody that is going to be using the drawing. So this, let me calculate the total number I need. So the total length in meter. So let me start with the 10 mm. Oh, 12 mm is not here. So let's go ahead. Let me start with the 10 mm enforcement. So just zoom this so I can see it once. I know I have 10 here and I have 10 here. The unit here is in millimeters, but I need to convert to meter. So let me just say 69,000. Okay, 69,000 is 69 meters. 69,000 mm is 69 meters. Just divide by 1,000. That's 69 plus 69. I'm going to have 138, right? 138. So the length for this 10 mm is 138. So let me just copy this and move it. 138. 138. Then for the 16 mm reinforcement, I just need to add everything up. Now let me zoom this and start from here first. For the 16 mm reinforcement, so I'm going to have 13,620. 13,620 plus 42, 42, then plus 76 plus 15.4, and that is where 12 mm stop, right? So I can just go to the other part of the beam. I'm adding the two beams together. Let's assume that is all the work we are doing. So in order to make this video short, this is 12,900 plus 72 plus 8076 plus 15.4. So that is that. So this is the value 84,396 in millimeter. Don't forget. Then I need to divide by 1,000 to have it in meter. So let's say it will be 84.4 meters. 84.4 meters. So I can copy this so I can use the 84.4 meters. That is 84.4 meters. That's the total length of what I need for the job. But you might decide to buy reinforcement in length. You can just divide by the length of one reinforcement, which is 12 mm, sometime 11.8. But let's say you want to buy in tonnage, and the value you have, you can take it to the market and request for the length of that reinforcement. But let's say you want to buy in tonnage. So in case you want to buy in tonnage, you just multiply this by this. This value is constant. The unit weight of reinforcement in kilogram per meter is constant. This is constant. So let me multiply this by this so I can have my answer in kg. So I can just have uh, 0.6165, then I multiply it by 138. So I'm going to have 85 kilogram, 85.1. Let me say 86. Copy. Okay, that is 86. And this is 84.4 multiplied by that value. 84.4 multiplied by 1.5783. So I'm going to have 134. So I have 134 here. So in case you are buying in kilogram, this is the value you will be buying in kilogram. In case you are buying in tonnage, just divide this by 1000. 86 divided by 1000 is 0.086. That's the quantity in ton. The quantity of 10 mm you need in ton. And 134 divided by 1000 is 0.134 tonnage. And that is the amount you'll be buying in ton. So this is how to do a bending schedule from AutoCAD. This is how to do a bending schedule. So you can continue with the rest if you wish to. But for the sake of this video, I just did this too for the sake of this video. So that's the way I'm going to go. I will just copy this and paste it here. Do for this again, do for this, and I'm going to have everything. Although when you model, software do come with they do come with bar bending schedule, but the reason why I don't use that of the software is because sometimes the software does not calculate for off cut. They don't calculate for the off cut. They don't calculate for the off cut. They just use a meter and add everything together. So from this value you have, you can add some quantity of waste to it. Just like I said, the reason why I don't use that of the uh, software is because it don't add value. You need to add a percentage for off cut for waste. But here now you can just add it. So that's why I said I'll be doing another. This is the part two. So in the part three, I'm going to be comparing two methods of Babin schedule. This is one method, right? I'm still going to bring this up in the third part of the video. This is one method which I don't normally use. So I'm going to introduce it to the method I use in doing my Babin schedule. And the reason why I don't use this is because most of the time someone might run at loss, especially if you are doing a short scale job. If it is not a large scale job, if you are doing a large scale job, this can still work where the client does not necessarily count every penny in the project. But when you are doing a small scale project that the client is after every penny of the project, if you need 10 length of enforcement, probably because you didn't do your bar bending schedule well and you went to demand for 8 and the client supply you or gave you money for 8, the money for it, and then you later come back that we still need 2 more length. The client might look that this man is not capable. He's not, he does not know what he's doing. But with this method I'm going to teach you, it's going to be very easy that you know the number you need and the off cut you need for the job. This is the second part of the bar bending schedule. Through the first part, and this is the second part. So I'm going to do a video on the third part where I said I'm going to show you a different method that I use in doing bar bending schedule. Thank you for watching.